Hello, ladies and gentlemen. My name is Paola Carvalho and I will present the work named Numerical Modeling of Heat and Mass Transfer during the wood drying process, with the collaboration of Viviana Mariani. First of all, this presentation is divided in 5 parts: introduction, model where we expose the simulation parameters, numerical method, result and discussion, and finally conclusion. The applicability of wood is mainly due to the great difference of species and the different drying process, once each type of wood has anatomical characteristics and thermophysical properties that directly influence its industrial use. This process facilitates handling, transportation, some processes such as sanding, and makes dimensional variation difficult. Furthermore, the moisture removal helps to eliminate fungi and pests, reduce stench and rot. Moreover, the wood drying improves the mechanical resistance, thermal, acoustic, and electrical insulation properties. So, drying is an essential process for importation and exportation of wood, once it eliminates the risk of transporting and transferring harmful microorganisms that can threaten some native species to destination countries. However, it is a delicate and complex process. All operating conditions must be adequately controlled, specialized drying speed and temperature, to make the process effective and thus avoid any damage to the product. Considering that the drying occurs by the superficial water removal due to the heat transfer between the wood and the air, and by mass transfer, as it is the displacement of the wood internal water to its surface and later to the air current. The computational simulation helps to trace the wood characteristics, establish the process model that best suits its conditions, indicating which parameters are adopted, as well as the behavior of the drying process occurs. The object is to relate the drying time to the percentage of moisture in the wood, evaluate in two different border conditions. Therefore, the first is the condition of Newman and the second the condition of Dirac. The physical problem is consists of a piece of wood which can be represented in the Cartesian system with three-dimensional geometry. But for the computational code, simplifications were applied, like heat and mass transfer of the lateral faces are discarded, then it is one-dimensional domain, and the liquid water and air are considered incompressible. In this figure, in the letter A, you can see the three-dimensional geometry, and the letter B, the one-dimensional geometry. The equation 1 expresses the heat transferred, and the equation 2 and 3, respectively, the case 1 and case 2 for the border conditions, with the initial conditional is 10 graus Celsius. In the same way, in the equation 4 represents the mass transfer, and the equation 5 the border conditional to case 1, and the equation 6 the border conditional of the case 2, which the initial conditional will be 75%. In the both cases, in the middle plane, we have the symmetry conditions, that is in the heat flow and the mass and the moisture diffusion flow are null, as shown with the equation 7 and 8. Some simulated parameters are temperature equal to 25%, relative humidity equal to 50%, our temperature equal to 25 degrees Celsius. Sorry. In addition, using TDMA, time stepping, and MATLAB software as a solver, solving the equations decoupled and applying the finite different method. The table in the you can see other parameters like mass transfer coefficient, density of wood, so in equation 9 and 10 represent the equation of heat and mass transfer in the discrete form, and equations 11 14 represent the letters of the equations 9 and 10. The code validations was performed through the study by Simon Tegnin in the year 2016. After validation, the model as study of computational mesh was carried out in order to refine it and improve the accuracy of temperature and humidity values. Therefore, the mesh was tested with 12, 48, and 192. And then, to verify the conversion of a quantitative analysis, the performance indications were calculated, which are coefficients of determination and root mean square error. The developed code was validated with the code proposed by Simon Tegnin. The results obtained was similar to results for temperature and moisture, respectively. You can see in the figures. And you can see also the values of the performance indicators. In the case of pine wood, the values for performance indicators are better for the refined mesh, like the flake wood. And you can verify that the temperature increases as time elapses, and consequently the moisture percentage present in the wood decreases. Indicates the expected behavior for the drying process, since the moisture present at the end was less than 25%. The value represents a significant increase in drying wood quality. And you can notice a small difference between the results for the temperature evaluation and the moisture contained between pine and flake wood. This is due to the change in specific mass in the mass diffusion coefficient and the heat transfer coefficients and of mass. However, this variation is small because both species have the same botanical origin, that is, they are softwood, which are light and softwood made up of a simple structure. In the curves in case 2, show current behaviors and results that different from case 1, especially regarding drying time. To reach 12% humidity was required a drying time approximately 3 times longer. This fact is linked to the assumptions of the absence of convection and heat conduction, which accelerate the removal of moisture from the wood. On the other hand, this time increase leads to increased operation costs for drying in general, among which can be mentioned storage space, energy, and production quantity. In the same way, when analyze the behavior of flake wood in the same way as pine wood, through the methods of case 1 and 2, obtains a result similar to the of the pine wood, since through the condition of case 2, the time required for the process to reach the same moisture content is longer. Finally, the validation of the computational code developed by comparing the initial results provide greater security in the results obtained for the pine wood. The developed code describes the pine wood drying process with satisfaction, so it can be used as a tool to ascertain it. And the boundary conditions influence the drying process parameters, since which the change of the direct conditional to the numerical conditions, there was an increase in operation costs. And for the future studies, suggest that different numerical schemes may be applied, being implicit in time, such as Craig-Nixon, or explicit modes, such as Euler. Then compare the results by checking which one has better conversions, greater numerical stability, and security of temperature and humidity values for pine wood. Sorry for that. Thank you very much for the time to watch me. And if you have any questions, please contact me. Bye bye.